Alright guys, so in this video I'm going to take us through how to solve a system of linear equations. In this video I'm going to just start with two equations. So the system is going to have two equations. I'll label them equation 1 and this will be equation number 2. So how do we solve them? What do we mean by solve the equations? What we're looking for are a value of x and y that will satisfy both of these equations. We want to find that value of x and that value of y that satisfies both of these equations, assuming that such a value exists. All right, so how do we go about that? Well, I'm going to just do it algebraically first, and then I'm going to sort of talk about what we're doing in terms of a Cartesian coordinate plane. So these are linear equations, meaning that they are equations with x raised to the power of 1. Right, so this is 3x to the 1, 3x to the 1 here, and so linear. Right? If it was x to the power of 2, that would be quadratic. X to the power of 3 would be cubic. So these are linear equations. So this is where we're starting. How do we solve it? Well, we have two equations with two unknowns. And what we ultimately want to do is get to a situation where we have one equation with one unknown. The easiest way to go about doing this is to simply manipulate the equations using math operations like addition or subtraction, which result in one of the variables canceling. If I look at my particular equations here, I notice that I have a 3x in equation number 1 and a 3x in equation number 2. That means that if I subtract equation number 2 from equation number 1, if I subtract 2 from 1, then the x's will cancel because I'll have 3x minus 3x, and the x's will cancel. So that's what I'm going to do. So under here, I'm going to draw a line. I'm going to have minus. I'm going to put a parentheses because I need to be careful because I'm doing subtraction here. So you need to be careful. It's a minus on everything behind that parentheses. And so I have 3x minus 3x. That's 0x. I have 4y minus 2y. A minus times a minus gives me a plus, so I have 4y plus 2y, that's 6y. Plus 6y, I have an equal sign, and I have 7 minus 1 is 6. And so notice that again, I have gone from two equations with two unknowns, x and y, to one equation with one unknown. 6y is equal to 6, I have one unknown, that's y, and so therefore I can solve for that one unknown. And so, if I divide both sides by 6, left and right, I get 6 over 6, which is 1. And so I'm getting that y is equal to 1. I need to find now my x value. The easiest way to do that probably is just to substitute back in my y value into one of these equations. And so, I'll just take equation number 1. Equation number 1 now becomes 3x plus 4, and then I now know that y is 1. So I can substitute in that value. 1 is equal to 7. So therefore, 3x plus 4 is equal to 7. And 3x is equal to, subtracting 4 to the other side, 7 minus 4 is 3. And if 3x is 3, I can divide both sides of this equation by 3. I get 3 over 3, which is 1. And so again, I have x is equal to 1. And so my x, y, the values of x and y that satisfy both of these equations, let me put it that way, is 1, 1. All right. X is equal to 1, y is equal to 1. Satisfies both of these equations. And in fact, we could even just sort of check that real quick. 3 times 1 is 3, plus 4 times 1 is 4. 3 plus 4 is indeed 7. 3 times 1 is 3, minus 2 times 1 is 2. 3 minus 2 is indeed 1. So you can see that these values of x and y satisfy both of these equations. Okay, let's do another one like this that is somewhat more challenging. So again, I want two linear equations. The two linear equations I'm going to take are x plus y is equal to 2, and 3x minus 2y is equal to 6. Okay, again, I will call this my equation number 1. This here will be my equation number 2. Again, the same idea. I have two equations with two unknowns, x and y, and I want to use some math operations, again, typically addition or subtraction, in order such that I will end up with one equation with one unknown. That involves one of the unknowns, one of the variables, x or y, canceling. You'll notice that I don't have any coefficients that are the same this time. In the previous question, I had a 3x and a 3x. Here I have an x and a 3x, and I have a y and a negative 2y. What I notice that I can do, what you're going to have to be able to spot as you're doing these problems, is that I have a couple of options here. I could multiply both of this top equation by 3. And then I would have 3x plus 3y equals 6. That would be the top equation, equation number 1 multiplied by 3. Then, because I would now have a 3x, and here I have a 3x, I could subtract the equations. So I could do that. The other option I could do is, because I have here a 2y, I could multiply this first equation by 2. And that would give me 2x plus 2y equals 4. And then I would have a plus 2y in my first equation, and I have a negative 2y in my second equation. And if I were to add those equations, add them, the 2y plus negative 2y would cancel for me. And again, that cancellation is what I'm looking for. So I'm going to go with that second option. What I'm going to do is I'm going to multiply this top equation by 2. I'll just put it down here. That would give me, remember it's 2 on every term, so that's 2x plus 2y equals 4. Okay? And now, so this is my first equation, just multiplied by 2. I can now add these two equations. So I can now add this equation, equation number 2, to this equation right here, which is simply equation number 1 multiplied by 2. And what that will do for me is I have now set up a situation where if I add them, my y terms will cancel, which is what I want. So I'm going to go from two equations with two unknowns to one equation with one unknown. So 3x plus 2x is 5x minus 2y plus 2y, well, they cancel. I'll just write 0y, omit that if you like. And 6 plus 4, that's 10. And so I'm left with 5x is equal to 10, one equation with one unknown. And so dividing both sides by 5, I get x is equal to 10 divided by 5, that's 2. All right, so that's my x value. Again, what do I have to do now? I have to find my y term. I'm just going to erase this. And I'm going to substitute back in to either equation 1 or 2. It makes no difference. My value for x. I think equation number 1 looks pretty straightforward, so let me just substitute it in there. X plus y equals 2 becomes 2 plus y equals 2. So this equation here now becomes 2 plus y equals 2. I've substituted in my x value in here back into equation number 1. And so 2 plus y is 2, subtracting my 2 on the left-hand side over to the right-hand side such that I get y by itself. I get y is equal to 2, and this is minus 2. I'm subtracting 2 from both sides. That way. And so y is 2 minus 2. Y, therefore, is 0. And so I have an x term of 2, a y of 0, and so my x, y values that satisfy these two equations is 2, 0. All right? And that is how we solve this system of equations, right there. That is how it is done. Or at least that's one way, and a pretty common way to do it. What this means, notice that again we call these linear equations. Why do we call them linear equations? Because if we were to plot these two equations on a Cartesian coordinate plane, we would make a line. They form a line. X plus y equals 2 on an xy coordinate plane would make a line, and this is also in the shape of a line. And this, by solving this 2, 0, represents the point at which those two lines intersect. And so it is the value of x and y that is common to both lines. That's the point of intersection of those two lines. And so that's what we're doing when we solve the system of equations. We are finding the point that is common to both of them. All right, I want to show you one last thing, and that is I want to talk about slope-intercept form of a line. So how do we go from this form right here to slope-intercept form? So I'm actually going to solve this system of equations again using sort of a slightly different method, even though ultimately it is the same idea, but I want to show you another way that you can do it by first putting them into slope-intercept form. All right, so I'm going to use these two lines. Bear in mind that this is our answer, 2, 0, so we know what the answer is going to be, assuming we do it correctly. So let me just get rid of this. Get rid of all this. I'm going to keep, let me just get this guy, I'm going to put in my 2y here. Okay, so I'm going to convert both of these lines to slope-intercept. I'm going to just put this over here, okay? So what a slope-intercept means is that you have y on the left-hand side of the equation, typically it's the left-hand side, y on the left by itself. So it's by itself, it's positive. And so, y is already on the left-hand side of the equation, but it's not by itself. It has an x accompanying it. So we want to subtract that x to the other side. And so that will give me y is equal to negative x plus 2, right? There's already a plus 2 on the right-hand side, so that stays there. And that's it. That was a pretty straightforward one. These two equations are completely equivalent, but this has been rearranged into what we call slope-intercept form. All right, I'm going to do this one. Looks like it's a bit more involved. So let me just put a box around this. We know that that's that one. We just go down, I'll actually write down here. So 3x minus 2y, well, I will subtract my minus 3x, and I will have minus 2y is equal to minus 3x, subtracting it to the right-hand side, and I have a plus 6 over there. Not quite done yet, because I don't have y by itself. I have a minus 2 in front of it, so I need to divide both sides of this equation by minus 2, such that I get y by itself. And so I get y is equal to, if I divide minus 3x by minus 2, I'll have a minus divided by minus, that's plus 3 over 2x. So I've divided this term here by minus 2, a minus over a minus gives me a plus 3 over 2 times x. If I divide 6 by minus 2, that's a positive number divided by a negative number. So that's negative. 6 divided by 2 is 3. And now this is also in slope-intercept form. So this here is equation number 2 written in slope-intercept form. This coefficient right here, the coefficient on the x, is the slope of that line. In this case, that slope happens to be 3 over 2, and this minus 3 is the y-intercept. So this here is the slope. That's the slope, which is 3 over 2, and this here is the y-intercept, and that here, right here, and that is equal to negative 3. Y-intercept is negative 3. Don't forget that minus sign in front. It's very important. A lot of students drop that. Over here, my slope is, again, don't say that the slope is negative x. It is the coefficient that is on the x. In this case, that is, slope is minus 1. Okay, the slope is minus 1, and my y-intercept, this is my y-intercept, that's plus 2. And so, this line here has a negative slope of minus 1, and it crosses the y-axis at plus 2. That would be enough information now for me in order to sort of graph that, if I had some graph paper. Here, I have a slope of 3 over 2, and it crosses the y-intercept at negative 3. Again, just that information alone would be enough for me to graph that on a Cartesian coordinate plane. I want to show you how we can now actually solve this system of equations using this method. Now that we have both lines in slope-intercept form, I'm just going to erase this here, so a little bit more board space. So what I'm actually going to do Notice that both of my lines are in the form y equals to this, and then y, and over here, let's clear that up. Here I have y equal to. So what I'm actually going to do is I'm going to let this here equal to this, because I have y equals to my 3 over 2x minus 3, or these two terms, and I have y equal to these two terms. So what I'm actually going to do in order to find the value of x that's common to both is I'm going to let just this, the terms on the right-hand side equal to each other. And so I will get that 3 over 2x minus 3 is equal to minus x plus 2. Okay? And now I can solve for x. I'll bring my x terms all to the left-hand side, and I will bring my constant terms to the right-hand side. So that will give me 3 over 2x. When I'll add x to both sides, I will bring the x over here, plus x is equal to, I have 2. If I add 3 to both sides, 3 will go to the right-hand side, and I will have plus 3. 3 over 2x plus x, so this is 1.5x plus 1. It's 2.5, or 5 over 2. 5 over 2x is equal to 2 plus 3 is 5. And therefore, x is equal to 5 divided by 5 over 2, which is, remember how to solve fractions from elementary school, that is 5 times invert the denominator, 2 over 5, which is 10 over 5, which is great, that's 2. Happy to see that it's 2 because we know we've solved this problem already. We got 2 previously, so it's good to see that we're getting 2 again. In order to solve for y, what do you think I'm going to do? Well, of course, I'm going to just simply input my value of x into either of these equations is fine. Let's just input it into, let's put it into this one. So that will become, so I'm inputting my value here of x, too far, putting it in here, in for this x right here. So that's where I'm putting it. I'm going to put it in there, and therefore solve for y. So y is equal to 3 over 2 times 2 minus 3. And so I get that y is equal to 3 times 2 is 6 over 2 minus 3. 6 over 2 is 3 minus 3, which is 0. Excellent. Because previously I found that my point, the solution to these equations was 2, 0, and so it's nice to see that I found that I get the same answer using this method. And so my xy value is, again, just the solution is 2, 0. And so if you were to graph these two lines, you take out your graphing calculator, for example, and you were to graph these two lines, you would find that their point of intersection is at point 2, 0. That is the solution to those equations. That is the values of x and y that satisfy both of those equations. So that is how to solve a system of linear equations, a system of 2 linear equations. Later on, I'm going to show you how to solve a system of 3 linear equations. A little bit more difficult, but I think, as you see, it's much, a lot of the techniques we've used here, we're going to use again. All right, thanks a lot.